Hey guys, welcome to Path to Math. Today we're going to practice SAT non-calculator practice problems, including some that are FRQ. FRQ, aka grid and response questions. So for number one, we have a fraction here, 8 to the third power over 2 to the sixth power, and the expectation is to simplify. This is a great FRQ problem. We're going to end up getting a numerical value at the end. This might come up as a multiple choice or FRQ. Let's get to the point though. We have to simplify this fraction. And by simplifying this, we're going to want to combine the exponents somehow. So what we're familiar with is typically with letters. When we have a letter on top and bottom of a fraction and they have exponents, we just subtract the exponents. So we would get 4 minus 2, which is x squared. And that's how we could simplify that exponent. But in this example, we have numbers. So be careful with numbers. This is like having x to the fourth over y to the second. Now we have two different variables in this case, so we can't really well, I put an x, but we can't really simplify that. We can't do any further simplification in that example. So what we have to do to our numbers is we have to apply change of base. We have to change one of those base values, either the 8 or the 2, to match the other one. What we can identify is that the 8 can be rewritten as a base of 2 to what exponent? To the third exponent. 8 is 2 to the third power. 2 times 2 times 2 is 8. What we're allowed to do is we're then allowed to substitute the 8 for 2 to the third power. So be careful when you do this, because you have now a power to power. 2 to the third power. When we have power to power, we have to multiply those exponents. That's going to give us 2 to the ninth power over 2 to the sixth. And now at this point, we could properly subtract those exponents, giving us 2 to the third power as our final answer, but more appropriately, we would have to do the math and have 8 as our final answer. All right, this is a single digit numerical answer. It's a positive value. That's how I could tell it's a great FRQ question. The FRQ questions max out at 5 digits, so you're not going to get 10,000 as an answer or anything like that. And I'll repeat it. You're not going to get any negative numbers for your FRQ grid and response problems on the SAT. Let's go over number 2. Number 2 says, if the x-intercepts of f of x equals x squared minus 4x are 0, 0, and a, b, find the value of 3a minus 1. So they're asking us to find the value of an expression, 3a minus 1. When they give you a lot of information, you want to always highlight the question that they're asking for. All right, you have to be able to understand what your endpoint is and what your end goal is. Now they gave us a polynomial and they told us 2 x-intercepts. Now one of them is 0, 0. So x-intercepts is a key word. How do you find the x-intercept of any graph? You have to plug in 0 for y, right? Typically for the y value, or in a quadratic, you're probably going to have to factor. We have a quadratic. I could tell we have a quadratic because we have x to the second power within my equation. Now, I could set this equal to 0. I got that equal to 0 because that's the y value, right? That's the y value that you have to plug in, that you have to plug 0 into. Now, as I factor this out, it's actually a relatively simple factor process. What's my GCF? My GCF is x. So I could rewrite this as x times x minus 4 equals 0. I basically pulled out an x from each of these terms. Now I could split this into 2 equations, x equals 0 and x minus 4 equals 0. This is how I can find my 2 x-intercepts. Obviously, they told us that 0, 0 is one of them, so that takes care of this left-hand side. But now it's our job to solve for the letter a. You see, 3a minus 1 is our expression that we need to find, and they said that a represents the x value of the x-intercept. Well, we're almost there. So x minus 4 equals 0. Just solve for the x value here by adding 4 to both sides. We get x equals a positive 4. If I were to continue, I would have to plug in, this would be the x-intercept. So the y value is automatically going to be 0. So I know that the a comma b translates to 4, 0. I found out that the other x-intercept is 4, 0. So I know that a is 4, so now I could actually solve for 3a minus 1. Plug in the 4 for that expression. and you're going to get 3 times 4 minus 1. That's 12 minus 1. That's 11. So your answer is going to be 11 for this one. A positive number again, so another great FRQ problem. And yes, these are all non-calculator practice problems. All right, number 3. If we have a square, let's say if we have a circle inscribed inside a square, find the area of the square if the area of the circle is 36 pi. Okay, again, some information here. The goal is to find the area of the square. That's our end goal. Now let's draw a diagram to help us out. The word inscribed means the circle is going to be inside the square, but it's going to be touching each side. So for example, it's going to be perfectly fitting, if you will. A perfectly fitting circle. And that's not a great drawing, but you guys get the point. It's going to be meeting the points here, here, and here. All right. Now we know that the area of the circle, let me label this circle, is 36 pi. And the area of the square needs to be found. But I know that the area of the square is what? The area of any square, guys, that's just going to be base times base, or base squared. If you want to put length times height, that's cool too, but it's going to be the same value because we have a perfect square. So how can I possibly find the length of any of these sides? Well, I know that using the formula for the area of a circle, being pi r squared, I could find the radius of the circle. Let me draw the radius of the circle to help you visualize what's happening. And that's why this diagram is so important. Once I find the radius, if I can double that radius, I will have found the length of a side on that square. So that's like my key to getting the answer. I have to do this step first, and then I can get my final answer. Like I said, pi r squared is the formula. That will be on the formula sheet, but you should have that memorized. And so using this, I know that the square root, well, let me set the equal to each other. Pi r squared equals 36 pi. This is what's going on algebraically. We have the area that they gave us. I could set that equal to the area, the formula for the area. And so when I do this, I could quickly solve for r. I'm solving for r, which stands for the radius, to then find the side of the square. We could divide both sides by pi, giving us r squared equals 36, and then take the square root on both sides. So I know the radius is 6. The radius is 6. Now, a key detail that you don't want to make the mistake of is you have to double that value because the radius only goes halfway across the square. The radius is only halfway through the circle, right? So I have to double that to give me 12. 12 isn't my answer either. 12 is just one side on that square. So now I have to do 12 times 12, and that's going to be 144. And yeah, they would expect you to be able to do that without a calculator. 12 times 12, they're going to expect you to know that. I wouldn't go too much higher. Maybe 13 times 13 being 169. Not too much higher than that, though, in terms of memorizing your times tables. All right, number 4. A little bit simpler in terms of what they're asking for. They want us to solve for w, and here's the equation. Wx over x minus 4 plus y equals x. Okay, it does look like a bunch of mumbo jumbo, and they're going to mention x cannot equal 4. They only mention that because of the denominator. We can't have that equal 0 ever. There would be no solution. So they have to mention that. That's not going to change our answer. That's not going to change anything about what we do, really. So our goal is to isolate w. The first thing you should do when dealing with fractions within an equation is isolate the fraction and then eliminate the fraction. Isolate, then eliminate the fraction. So how do we isolate it? Well, looking at the left-hand side where the fraction is, we could subtract y to both sides. If we subtract y to both sides, that would then isolate our fraction. So minus y. It's going to give us wx over x minus 4 equals x minus y. Now I want to eliminate the fraction. I eliminate the fraction by multiplying both sides by the denominator. And so we're going to multiply this left-hand side by x minus 4. I'm going to multiply this right-hand side by x minus 4. That's going to give us wx equals x minus y times x minus 4. Understand that on the left-hand side, the x minus 4 is completely canceled top and bottom. All right. Now, the last step is to divide both sides by x. So w equals x minus y, x minus 4. Sorry, those are x's. Divided by x. This could be a final answer. It could be. But most likely, they're going to expect you to actually FOIL that numerator. So let's go ahead and take a moment and FOIL that numerator. When FOILing, I know it sounds kind of simple for those of you who are familiar with this, but I always draw the rainbows. I just always do. So we have x squared minus 4x minus yx, and then plus 4y. All that's going to be divided by x still. Now, as much of a mess as that looks like, there's really nothing else we could do to simplify. There's no like terms that match exactly that allow us to combine anything. For example, that negative 4x, it can't be combined with the minus yx. The plus 4y, that doesn't combine with anything either. There's nothing else we could do. This would be your final answer for this problem. Obviously, this is not an FRQ question. There would be multiple choice options. And what's tricky about this is really that last step, the FOILing. You can do all that work, but if you're going to rush yourself because you're going to be having time constraints on the SAT, they're going to try to catch mistakes that you make. An option, for example, let's say option B, it might be x squared minus 4x plus yx minus 4y all over x. All they did was switch out those plus and minus signs, and if you were a little bit too rushed or too quick, you may have made that mistake and had an exact match, and you would have put B as your answer, and you would have been wrong, even though you did most of the work correctly. So be careful about that. There might be 4 options that look similar to this. You got to be able to just take your time, double check your work, and make sure you get that right answer. All right, guys, that's all for today. Feel free to request any other content on math, and I'll be happy to cover it. Subscribe and click the bell notification so you can see the video when I post it dedicated to your request. And other than that, thank you guys so much for supporting. Have a great day, and good luck on the SAT.